Hello everyone! In this tutorial, we will examine a simple Blender scene to be used for creating a turntable animation of any 3D model. These animations are required by some stores where you can publish your 3D models. They consist of a series of images in which the 3D model to be proposed rotates 360 degrees, typically around its vertical axis. This tutorial was created with Blender 3.3, but the elements we will discuss are available from several previous versions and, presumably, will still be in the future. It is a tutorial aimed at beginners, in which we will examine some basic tools such as the Track to constraint for the camera and the lighting of the scene. Before we go on, I remind you that, as it happens with most of my tutorials, the text version of this video tutorial is available for free download at the link provided in the description. In this tutorial, I will use a 3D model called Tableware Set 1. This is a model containing multiple objects, which will allow us to see how to handle models of this type to create turntables. However, it is not necessary to have this 3D model to learn from this tutorial. You can also watch the tutorial without downloading this particular 3D model. In the first part of this tutorial, I will show you the basic scene without a 3D model to list the various settings of the template file to be used as a starting point for all the models to be framed and rendered. In the second part, we will see a practical example with the 3D model I mentioned earlier, so as to see how to create the rotation animation. So, let's start with the first part of the tutorial. In the scene there are 5 objects, 3 light-emitting planes, a virtual camera, and an empty object positioned at the center of the virtual universe. The empty object serves as a reference point so that the virtual camera and the 3 light-emitting planes correctly point towards it. This is important because we need to adjust the framing based on the size of the object to be framed. By using the empty, we won't have to operate individually on the camera and the planes, but it will be enough to move the empty for the other objects to automatically follow it. This is achieved through the use of the Track to constraint, which, as the name suggests, makes the object that owns it automatically follow the target object. To correctly set the Track to constraint, we need to specify 2 directions, the front vector and the upper one. The front vector, called track axis, indicates in which direction the object will point. In the case of the main camera, it is the local negative z-axis, as can be seen by selecting the main camera and setting, in a 3D view, the viewport gizmo move and the local transform orientation. The positive local z-axis points towards the back of the frame, so we need to set -z in the track axis field of this object. This display mode also allows us to easily identify the upper vector of the main camera. It is positive y, so in the up field of the Track to constraint, we will select y. All that remains to do is specify the empty object as the target, and the camera will always point towards the empty, even when we move the main camera within the scene. Another setting concerning the main camera is its focal length, which is found in the Object Data Properties tab of the object. In this case, it is best to set a high value, for example 18 or 110, to reduce the distortion effects due to perspective. Anyway, we will see a practical example soon. Now that we know that the camera's framing axis is local z, we can also move the camera away from or closer to the empty by moving along that axis, simply by using GZZ. The Track to constraint should also be set for the 3 light-emitting planes. Here, however, we notice that the positive axis that is perpendicular to the planes, which coincides with their normals, is positive z. So in their Track to constraint I will specify z. Regarding these 3 light-emitting planes, there isn't much to say. They are, indeed, 3 planes provided with an emitter material. providing default white lighting with equal intensity, but the three planes are of different size, and this affects light intensity and shading in general. The three planes are arranged to achieve a standard 3-point lighting, but the settings listed so far are just the starting points. Nothing prevents you from changing the intensity, color, or arrangement of these three lights in the scene, depending on your needs. The three light-emitting planes are not, however, the only elements related to lighting. In the World Properties tab, I have set an EXR image with linear color space to illuminate the object. The choice of the image depends on various factors, but in general I use colored images rather than images that reproduce studio lighting when framing objects with many metallic components, in order to achieve interesting and non-monotonous shading effects on those very reflective surfaces. As previously stated, these are just the initial settings to have different lighting options, but of course, you can also deactivate the three light-emitting planes or reduce the intensity of the world background lighting, depending on the needs of the scenes. The rendering preview can be evaluated in real time by switching to the rendered display mode, as we will see later with a practical example. Regarding the rendering of the scene, most of the time the store requires sequences of images. The specifications vary for each store, and the parameters to be set in the Render Properties and Output Properties tab must be set accordingly. In my case, in Render Properties, I set 250 samples for rendering, and most of the time it is not even necessary to activate the denoise, because the noise in a scene like this is minimal, and the fireflies can be reduced by setting the value to 0.99 in the clamping fields. Moreover, the noise could have effects on the details of the surfaces of the objects, so I prefer not to use it in this case. As for the output specifications, in my case I set the resolution to 9020 by 1080, because for many stores it's sufficient. Also, I chose the PNG RGBA format, which is a sequence of images with a transparent background, because various stores have different background requests, so here I prefer output with transparency. Speaking of the transparent background, to not display the background of the virtual universe in the renderings, you need to open the Film tab in the Render Properties window and select the Transparent option. The last setting for this template file concerns the timeline and, in general, the duration of the animation to be made. These parameters depend on the requirements of the various stores, so here I will show a couple of examples. If the store requires a movie, or if you intend to make a movie clip to publish on YouTube, on social media, or on your website, then you need to set a number of frames equal to the duration of the animations in seconds multiplied by the desired number of frames per second. For example, to make a 10-second movie to play at 25 frames per second, you will need to set 250 in the end field of the timeline. Plus, in this case, you can opt for making a movie file rather than a sequence of images in the Output Properties tab. If instead you need to create a low number of single images, for example 13, then it will be sufficient to set the exact number of images to be created in the end field of the timeline. Blender will create an image for each frame of the animation. These are the general settings of the file, valid for all 3D models to be rendered. This file can then be saved as a general template in a separate folder, to make copies to modify for specific projects. So let's see a practical example with a 3D model, which can be imported into the scene using Append or Asset Browser. I chose the TableWare Set1 model because it consists of many objects, so it will be necessary to group them or merge them into a single object in order to correctly set its origin and easily perform some transformations. As soon as it's imported, the model is huge and doesn't fit within the frame. Before resizing it, however, I'll merge it into a single object with join. Now, though, all the individual objects that make up the set are selected, but there isn't an active object, so join cannot be done correctly. To solve this problem, I press Shift and the left mouse button on an object, such as the placemat, whose outline will change color to indicate that it is now the active object. I then press Ctrl J to merge all selected elements with the placemat object. The placemat has its origin coinciding with the center of the scene, so I can resize it by simply pressing the S key and moving the mouse, then pressing Enter when the object fits into the frame. If the imported object does not have its origin in the center of the scene, you can manually position it as you wish, then press Ctrl A and choose Location. This operation will have the effect of resetting the object's location coordinates. The result of this operation is that the object's origin will coincide with the center of the virtual universe, as desired. Now the objects fit within the frame, but there is a problem. This frame is not ideal for displaying this particular model. Here we have two possible solutions: moving the virtual camera up or rotating the object around its x-axis. The choice depends on the model in question. If the object also has details on the bottom, then it's probably better to rotate it around the x-axis, tilting it a bit, before performing the animation around the global vertical axis. If you decide to follow this method, remember to apply the rotation transformation with Ctrl A, rotate, and, if necessary, move the object and apply the location transformation again, in order to correctly set the origin of the rotated object in the center of the virtual scene. In the case of TableWare Set1, however, there are no details on the back of the model, so we can proceed with the second option, moving up the virtual camera. This operation can be easily performed by selecting the virtual camera and moving it with a transformation gizmo in the 3D view, or with the GZ shortcut. Nothing prevents you from starting with a different framing, moving the virtual camera to other points in the scene. Note that since the virtual camera always points towards the empty located at the center of the scene, there will be no need to modify the rotation of the camera. You can also move the empty to fix the framing. This is particularly useful with the model I'm using in this example, because in fact the center of its bounding box does not coincide with the center of the virtual universe, so it is necessary to move the empty upwards and, consequently, the framing, to observe it better. Also in this case, the use of the Track to constraint for the camera shows its advantages. In the first part of the video I told you that it is advisable to use a high value for the focal length of the virtual camera to limit distortions due to perspective. You can get an idea of these distortions by now changing the value of the focal length of the main camera. Besides the fact that you will need to move the main camera forward or backward to frame the object well, you will immediately notice the distortions with low focal length values, especially at the edges of the frame. Therefore, I recommend a value between 80 and 110. I don't think there is a need for higher values, but, as always, the final choice should be made by examining the specific model each time. Okay, let's move on to the animation of the model. Actually, the operation is very simple. Since we want a 360-degree rotation around the vertical axis, we only need to set two animation keyframes at the first and the last frame. With the 3D model selected at frame 1 of the timeline, make sure that the rotation values in the Transform tab are initially reset to 0. Then right-click on Rotation Z and select the Insert Keyframes operation. Then go to the last frame of the animation, enter 360 in the Rotation Z field of the object, right-click and choose the Insert Keyframe operation. The animation of the rotation has been created, as we can see by clicking on the play button of the timeline. If the number of frames is very low, it might be preferable to move forward and backward between the various frames by pressing the arrow keys. However, before starting the rendering of the sequence, we still need to perform three operations. Check the lighting of the model. Check the framing throughout the animation. Modify, if necessary, the interpolation between the various keyframes, i.e., the way Blender will perform the object's rotation in the intermediate frames. The lighting of the model can be checked by pressing the Z key and switching to Rendered View mode. In this way, by examining the model in various frames of the animation, we can decide whether to keep the default lighting scheme or whether to change the settings of the three emitting planes or change the EXR or HDR image used in the world background. The framing check is done simply by examining the various frames and concerned models whose bounding box is not cubic and is not centered in the scene. Just like in our case, table where set 1 is, in fact, longer than it is wide, so in some frames it might go outside the frame. In this case, it will be necessary to adjust the distance of the camera from the framed object or the height of the empty, so that the object is within the frame in all frames. This operation is also useful to prevent, on the contrary, the object from unnecessarily occupying too small a portion of the frame. The last operation to be done concerns the analysis of the interpolation between the various keyframes. Blender can indeed perform different types of transitions from one keyframe to another. For example, an interpolation with a Bezier curve will start and end the animation between the two keyframes gradually rather than linearly. In our case, however, a linear animation might be preferable. The interpolation between the keyframes can be modified in the graph editor. With the 3D model selected, we open the graph editor, select the two animation keyframes available there, then press the V key and choose the type of interpolation we want to achieve for our animation. In my case, the interpolation is already of the linear type, because I have set it as such by default for all my Blender projects in the Animation tab of the Preferences window in Default Interpolation, but I wanted to show you how to modify this aspect anyway. To sum up, in this tutorial we have seen how to set up a simple scene to obtain a turntable sequence of images of a 3D model in Blender, choosing an appropriate focal length for the virtual camera and setting up good lighting for the object to be framed. We have seen how to set the Track to constraint to point the light sources and the camera towards the center of the virtual scene. We have also seen how to properly set the origin and the rotation of the objects to be framed, and how to create animations with the desired number of frames. Finally, we have also seen how to modify the interpolation of animation curves to obtain linear rotations of the 3D model. I hope this simple tutorial has been useful to you. See you soon!